Yesterday we looked at, I guess we'll call it arithmetic with functions, like adding, subtracting, multiplying, dividing. Today we're just going to look at composition. So what happens when you put a function inside a function? And there's two notations you're going to see for it. This is the one here, and it's this dot operator. That means composition. And it's the equivalent of what I've written down here. So this one is a little bit harder to read, but the way it's written here is read as g of f of x. So you read it left to right like you normally would in English, so it's g of f of x. So you're putting a function inside of another function. And I'll show you what it's one of those things that makes more sense once you see it happen. So let's take a look at this first example. This is like saying, what's f of g of 2? So the first thing you have to be able to resolve is what's g of 2? So we can go into this equation here, and I'll have 2 squared plus 2, that's 6. So I'm looking for f of 6, which is 18. Okay. It's like a dream within a dream. If you haven't seen Inception, that was the reference made anyways. So now we're going to take a look at the, what if we don't have a number? What if we have to put the function inside of another function? Well, it's similar to what we did yesterday. We're just going to use the algebra to replace it. So g of x is 3x. I'm going to call this f of 3x. Oops, sorry, g is actually x squared plus x, so it should be this one. Okay, so all I did was I took the value for g and I put that function where it used to be. So this would be, what does the function f do to things? It multiplies things by 3. So you put in an x and I'm going to multiply that x by 3. So that's all that happens here, is I get 3 times x squared plus x. So you could write this as 3x squared plus 3x. Okay, so give it a try. See if can you do f of g of 2x plus 1. See if you can unravel the functions there. All right, so if you make this substitution into the first function, you're looking at unraveling this. So I'm going to be dealing with g of x squares it and adds the value, so it's going to be 2x plus 1 squared plus 2x plus 1. And then the function for f, it triples things, so that means I'm going to, whatever I put in for x gets tripled, so it's going to be 3 times, suppose I'll use these brackets just to make them look different, 2x plus 1 squared plus 2x plus 1. Okay, and now you could expand it and etc., but that's not the point of our lesson today. So that's enough to call this one finished. But we could, of course, like I said, expand it and collect like terms, and we get another quadratic equation out of it. Okay, so this time let's talk about composing these two functions. The first function is the square root of x minus 3, and the second one is x squared plus 2. Okay. So the first time, try f of g of x. What's the new function that you get when you do f of g of x? Okay, so for the first one, maybe I'll just walk through again just while you're getting the hang of it. You're putting in the function g of x, and here's what it looks like. So x squared plus 2 is what I put inside of f. And what f normally does is you give me a value here, and I place it right there. So it doesn't matter what you give me. If I wanted to say, what's f of purple? That doesn't make very much sense, right? Because you're used to like numbers and letters. But all this thing does is it takes purple minus 3 and square roots it. So whatever you put in, that's where it goes. Same as here when you're using the x. So if I wanted to simplify it then, x squared plus 2 is going to go in where it used to be, and I get square root of x squared minus 1 once it's all done. Okay. And if we practice that with f of g of 2, you would end up with 2 is going to be, let's see here, 4 plus 2 is 6, so that'll be f of 6. And then f of 6 is going to be the square root of 6 minus 3, so that'll be root 3. Now, the next one is almost, it's similar, but it's not going to be the same. We'll take a look. We've switched f and g around. So g of x, this time you're going to be doing it, as you read it left to right, g of f of x, not the other way around that we just practiced. Okay, so try doing g of f of x and g of f of 2. So I did go around, I saw a lot of people have, they're on the right track here with this one, so I'll just, this is going to be root x minus 3. So whatever you put in for g, it's going to put it right there. So this is going to become x minus 3 squared plus 2. So x minus 3 plus 2. So x minus 1 was what we should have had for this. Okay, and then finally, if you're doing it at a value, that'll be g of f of 2. So at 2, probably should have picked a better number. Well, I'll have to make a change. Let's call it 4. I can't erase that one. My apologies. It was working well, but it won't work if we use 2, because as soon as I put in a 2, 2 minus 3 would be negative 1. Of course, then we're dealing with imaginary numbers, which, lucky for you, you don't need to know about till university.
You can't square that and then plus 2 is that? Is that possible?
No. But it's good for discussion because that's you're going to see when we have to look up the domains. Okay, so for this one it would be root 4 minus 3. So this is g of 1, which is 3. Now, when we do composition, the range of one graph becomes the domain of the other, right? Because whatever comes out of, when I make the composition f of g of x, this is now the domain of f, right? So if we want to know what's the domain of the new graph, we need to take a look at the range from the old one. So let's see here. If I had to say, here's f of x is x minus 3. So what can you tell me about this domain normally? Yeah, so x has to be greater than or equal to 3. Now when I stick in g of x, this is what you have. F of g of x. What could you tell me now about the domain? All I did was put the g of x where the x was, right? So I'm not asking for the whole answer, just what do you know about, if I use g of x in your answer? What do you know about the domain if you use g of x to describe the domain?
G of x is greater than or equal to 2.
Yeah, same thing, right? So this time it's g of x. Because I've made this composition, g of x has to be greater than or equal to 3 this time. What is g of x? Well, it's x squared plus 2. So I need to make sure x squared plus 2 is greater than or equal to 3. That's what I have to, in order to make sure that this thing works the way I intend it, that's the constraints I have to work under. Okay. So remember, this was taking from the old domain, and now we're trying to find how that function is going to obey it. So let me find out where that'll go. This will be x squared minus 1 greater than or equal to 0. It's always easier to talk about where something's positive and negative, right, than to talk about where it's, a specific point like 3. So this one would be x plus 1, x minus 1, and your most favoritist thing in the world? Nobody? It's not number lines? Are they your favorite yet? Okay, so at -1 and at 1. So x plus 1 will be negative over here, but positive everywhere else. X minus 1 will be negative there and positive there. So the only ones that I can use, positive, negative, positive. If this has to be greater than or equal to 0, then I have to be on this part of the number line, right here, where it's positive, and right there. So the domain that I get for the new graph is going to be x less than or equal to -1 and x greater than or equal to +1. That's from the number line on the other side. Okay. So there's my domain. What kind of a range do you think we'll get out of that graph? Can we get negatives out of a square root? No. Yeah, it's got to be greater than or equal to 0. So y greater than or equal to 0, since it has to be positives that come out of the square root. Okay, so I'd like you to try thinking your way through this one for g of f of x, and then we'll walk through it together once you have a chance to try it on your own. Okay, you can think about it the same way I did. Start by thinking, what's the domain of g of x? Okay, then f of x is going to become that value in your domain. See if you can make the substitution and work through it. Okay, I'm going to have to move some of my stuff here just so that we can talk about the next one. We don't need a number line for it, so I'll just get rid of my number line there. But what we're thinking about this time around, g of x is all real numbers if you're looking at x squared plus 2. There's no problem with the domain. I can use any value I want. Okay, so the only thing is now this is what I'm doing. So that's what I'm doing when I put g of x in. And remember I said the hardest thing people have is they do this, and some people will want to go like this, and they'll say, oh yeah, but Mr. Joyce, that's x minus 3 plus 2, that's x minus 1. No problems. That's just a line. All real numbers still work, and the range is all real numbers. But remember, only the first step is what counts. You did algebra to change the rest of it. So only this part here is the function. That's the new function. This is all changes you made through algebra. So if you look just at the first step here, that's what I want you to focus on. That's where you will always get your domain and range out of. So let's think about it this way. What's the domain now when you look at that one? Don't look at this. I know it simplifies, but what's the domain? Just look at the one I gave you. Yeah, it's got to be greater than or equal to 3. Otherwise, that square root is going to complain about it. Because I need to know the value of f of x before I can give it to g of x. That's why you can't just, I see this algebra down here that simplified it, but that only, I need to know this value first, right? You give me this number, then I square it and add 2. If the number doesn't exist, I can't give it to you to square it and add 2. So it's got to be greater than or equal to 3. What about the range? Again, think about just the first step there, that first graph we drew, or sorry, first equation we have. Well, when you square something, yeah, it can't be negative. So the smallest number, when you square something, what do you think the smallest number you can get out of it is? 0. This one's even better, though. It's plus 2. So 2 is going to be the smallest number you can get, and then everything above there. So y has to be greater than or equal to 2. Now, the other way I told you would be convenient to think about the range. The range is the set of values that come out of the domain. So if this is your domain, what values could come out of that? what I'm saying is if you started at positive 3 and went everywhere higher, your range will be at 2 and everywhere higher. Because putting in 3 would be 3 minus 3 is 0. That gives me a 0 plus 2 is 2. And then if you keep going, any other number you pick is going to be higher than that. Okay, so there's our domain and range for g of f of x. So finally, we have to be able to do this on a picture, which again, this is easier than thinking about domains and ranges. So let me walk you through the first one. Remember, the notation works like this. It goes from left to right. This should be g of f of negative 4. And then I'm going to go to my graph to find these values. And let's call this one f, and let's call this one g. So f of negative 4 is right here. That's equal to 0. So this is g of 0. And g of 0 is equal to negative 3. Okay, so we'll try another one, and then I'll let you do some on your own. F of g of 3. I'll do this one in green. So g of 3 is here. It's at 0. And I'm going to guess here that it's probably 2 1/4, something like that. I'll try and give you nice numbers if you're doing this for points, marks, obviously. So that'll be 2 1/4. Okay, so try doing it now for f of negative 2, and g of 3, and g of f of negative 5. So I'll try and catch up. I know some of you are still discussing it, so okay, so at negative 5, this one's negative 2, and g at negative 2. So it's right in the middle there between 2 and 3, so I'm going to assume it's negative 2.5. Okay, so I like the rainbow. I didn't even realize what I was doing there. It's nice, eh? It's exciting. It's pretty sad when that's the most exciting thing in your day, huh? I guess there was a code red drill, so. Okay, so I'll just, yes, question?
Could you show us how to do number C?
Number C, so f of negative 2. So the function goes back into itself on this one. So there's the notation, f of negative 2, that's f bracket negative 2. So here's my function for f, and I go over to negative 2, which is there. And it's 3 high. So that's how I know that this value is f of 3 right here. And f of 3 is this one, which is 1. So that's how I get my final answer of 1. Okay, so composition then. Here's just a quick little application. Back when people used to actually drive SUVs, there was a thing called a Durango. Anyway, it gets 5.9, it's a 5.9 liter engine, so it gets 0.2 liters per 100 kilometers. So if I wanted to give you, and you know, today I think it's a little cheaper right now, funny enough that gas went down in price, but it's about $1.45 was the week before. So write the volume of fuel by the distance. So if I wanted to come up with a volume by distance, it's going to be, if you give me the distance, you multiply it by 0.2, and that'll tell me how many liters that you've burned of fuel. And if I want to know what's the cost of fuel based on the volume, so the cost based on the volume, is going to be $1.45 times the number of liters that you use. And if I wanted to make a composite function to show you what the cost for every kilometer you drive is, well, what you're looking for is, you don't want cost by volume, you want cost by distance. So you want, can people see the orange okay, or should I switch back? Okay, well, I'll go to purple here. I don't want it in terms of volume, I actually want it in terms of distance. So that's how I get to distance, because when I put in the distance here, that'll give me the volume. Then the volume is used by the cost function to find the answer. So the composite function then would look like this. 0.2 times the distance. And I put that in for 1.45 times 0.2d. And that function there will tell you how much it costs for every kilometer you drive. Okay. There, so and you thought you'd never use this again after grade 12. So homework is up there for you to practice, and we will talk more about this next time when we meet.